Imagine you're on a sunny day at a park. There's a track where a cyclist pedals along swiftly, hair streaming in the breeze. We're going to talk about something called speed. Speed is really just how fast something moves, which means how much distance it covers over a certain period. If you watch the cyclist, they might cover a long stretch of the path in just seconds. We measure speed using a simple formula: speed equals distance divided by time. You'll often hear it in units like meters per second, m/s, or kilometers per hour, km/h. Now, picture someone sprinting on that same track. If they sprint 200 meters and it takes them exactly 20 seconds to do so, we can calculate their speed. You just divide 200, that's the distance, by 20, that's the time, and tar-da, you get a speed of 10 meters per second. That's how fast they're moving at that moment, which we call instantaneous speed. But wait, what if they slow down at a corner or take a quick break to catch their breath? Well, that's where average speed comes into play. Average speed is all about the total distance covered and the total time taken, even including any breaks. That's why average speed might be lower than the very fastest speed they reached while sprinting. Now, let's switch gears and look at something called a distance-time graph. Imagine it like a drawing, with the distance traveled shown up the side and time flowing along the bottom. These graphs help us see how fast or slow something moves. If the line is very steep, it's zooming along. If it's flat, the object stopped, like our cyclist catching a break. If the line curves, it means there's a change in speed, speeding up or slowing down. There's something else to notice, too. Sometimes the lines slope downward. This means instead of moving away, the cyclist or runner is coming back. A positive slope shows moving away, while a negative slope shows going back to where they started. We've seen different types of lines: steep ones, flat ones, curved ones, and downward sloping lines. By reading distance-time graphs, not only do we understand how quickly someone moves, but we also see how their speed and direction change as time goes by. It's like having super glasses for motion, showing us the whole picture clearly.